So here's my demonstration video for my A2 Electronics coursework project. The problem I've tried to solve with this project is the efficiency of solar panels. The problem with solar panels, or especially consumer grade solar panels, such as what you'd find have fitted on your roof or you'd buy to power or charge low power electronics, is that they are stationary, which means they don't obviously move. But the problem with that is when they can only get a high light intensity, natural light intensity from the sun at certain times of the day, based on the Earth's rotation around the sun, which for a lot of the time isn't allowing the solar panels to be used as efficiently as they could be. So the way I've tried to solve this problem is by creating an automated photosensitive pointing device. So everything's fully automated. The idea is that this LDR here, that's connected to the stepper, rotates and takes a pass of the room. It then stores the light intensity after each step. So in this case, I've got it 4 micro steps per one interval, which is the equivalent of 12 intervals for a full 360 degree rotation around the room. After each interval, after each interval, it stores the light intensity into this chip, into a buffer. It then runs through an algorithm. The code that's actually running the chip can be found on my GitHub page, which I'll leave a link for in the description. It then runs through the algorithm, finds the point at which this was looking at, and replicates that point with this stepper here, which wouldn't normally in actual production would have a solar panel attached to, or a plant, or something that needs to be pointed to the direction of most light. In this case, I'm just using a pencil to demonstrate or to show which way the stepper is actually pointing. Now this is actually calibrated in a minute, so we've got the LDR and the pencil pointing in the same direction. So if you want to come quick look at this circuit, it's quite a simple circuit in terms of hardware, but the actual more intricate stuff is actually happening inside the code. That's running on the 80MEGA328P microcontroller, and here I've just got 2 L293D motor driver ICs to control both of the steppers. I've also got, just for testing, I've got an artificial light source, which is just a fluorescent light, which normally would be the sun or some other natural light source. So to demonstrate this, I've got a normal power supply. I'm going to turn it on, and when I turn it on, you'll actually see this green LED flashing. Basically that's just to give you time to calibrate the system if you haven't already done it prior, which I have, so I won't need to do that. So I'm just going to power on the power supply, and I'm going to turn on my artificial light source, and then when the system finishes booting, I'm not sure where you can see that there, but you can see that the LDR is spinning and taking a pass of the room, and every time it stops, it takes the light intensity reading, stores it for calculation when it finishes. So we'll see it home itself, so the wire doesn't get taffled. Runs through the algorithm, and you can see that the pencil is now pointing towards the direction of most light. Now, just to prove that wasn't a fluke, I'm just going to move the lamp around slightly. It shouldn't have to move too far, but as you can see, the LDR is moving back around again, taking a pass of the area. And what you'll see the pencil do is it will home itself, so it will point to the direction it was initially when you first calibrated it, and then so it's homed itself now, and hopefully it'll come right back round and you can see it's pointing in the direction of most light. Obviously there's a slight discrepancy between the two because of the space and the fact that when the LDR was turning around, when it read the highest value was about there. Obviously that's going to be slightly different for this one because of the spacing. But yeah, that concludes my demonstration video for my A2 Electronics project.